All right, so let's get cracking on this solution. So I'm in the integer linked list class that was included with the starter project. And here's the insert sorted method. So I'll just delete this comment. And as we can see, it accepts an integer value. So the first thing we need to do is check whether the list is empty, because if the list is empty, we can obviously just insert the node. And the other thing that we're going to check is whether the first node in the list, so if the list isn't empty, we're going to check whether the first node in the list is greater than or equal to the value we're inserting, because in that case, we can just insert the new node at the head of the list. And so we're going to say if head equals null, because that means that the list is empty, or head.getValue is greater than or equal to the value we want to insert. In both of these cases, we want to just go ahead and add the new value at the front. So we'll just call our add to front method with the value, and we're done. And then of course we want to return. And so if the list is empty, we just need to add this new value at the front because it'll be in sorted order by default. Or if the head value is greater than or equal to the value, then we also know that the correct sorted position is right at the front of the list, because in the main method, we're always calling insert sorted. So the assumption that we're making here, and I'll put this in here, assumption the list is sorted. This wouldn't work. This part wouldn't work if the list was not sorted. Obviously, if the list wasn't sorted, we wouldn't even call this method. It wouldn't make a lot of sense. Okay, so assuming that we don't have one of those two cases, so we're not going to be inserting the new value at the front of the list, we then need to find the insertion point. So let's find the insertion point. Now, one wrinkle here is that we have a singly linked list. So what we're going to do is we're going to traverse the list looking for the first node with a value that's greater than or equal to the value that we want to insert. So let's say we find that node. And so let's say we have a current node, and that node is pointing to the node that has a value greater than or equal to the value we want to insert. Well, it's easy for us to create a new node and point that new node's next field to the current node. But what about the previous node's next field? It's currently pointing to the current node, and we need to change its next field so that it can point to the node with the new value. But it's a singly linked list, so if we only have a pointer to current, there's no way for us to get back to the previous node in the list. So we're going to have two fields, one for traversing the list, and then another field that's going to be one position behind the current field. And so when we finally hit a node that has a value greater than or equal to the one we're inserting, the previous field will be pointing to the node before that. So we'll say integer node current. This is the one we're going to use to traverse the list. It's going to equal head.getNext. We don't have to check head because we already did that here. And so if we're down here, we know that the value in head is less than the value we're inserting. So we don't need to check it again. But we're going to have a previous, and that's going to point to head. So when we start out, our current node is going to start at the head, at head.getNext. That's the first value we're going to check. And our previous node is at head. Our previous node is always going to be one behind the current node. And then we're going to say while current is not equal to null, and current.getValue is less than the value we're inserting, because the moment we hit a value that's greater than or equal to, we want to stop. While that's true, we're going to set previous to current, and we're going to set current to current.getNext. And so by doing this, we're constantly keeping previous one back from where current is. And so when we drop out of the loop, there are two possibilities here. Current is null, or current isn't null, meaning that we've hit a node with a value that's greater than or equal to the value we want to insert. Now, we don't have to handle the special case of current being null because we're not going to change anything in current. So we don't have to worry that, oh, we've hit the end of the list. If we have hit the end of the list, that means that we're going to be inserting the new value as the last node in the list, and that's fine. We don't have to worry about, oh, if we're at the end of the list, then we've got to do something differently. We don't have to worry about that, as you'll see. we now need to create a node for the new value. We need to set that node's next field, and we need to set the next field of whatever previous is pointing to point to the new node. And so we'll say integer node, new node equals new integer node for the value. And then we're going to say new node dot set next current, because we're inserting the new node before the current node, because we want to insert in sorted order, and we know that current has a value, is the first node we've seen that has a value that's greater than or equal to the value we want to insert. So we're going to insert the new node in front of current, so its next field will point to current, and now we have to handle the previous's next field, because whatever previous is pointing to, it now wants to point to the new node. So we're previous dot set next new node. And finally, we need to update the size. And that's it. So if we were inserting this at the end of the list, well, current will be null. So it's perfectly fine for us to say, you know, new node.set next null. It's sort of a redundant operation, but it's not expensive. So we'll just go ahead and do that. So let's go to our main method, and in here we've created 4 integers, 1, 2, 3, and 4, and we're going to insert 3, 2, 1, and 4. So let's run. And we'll see that we start out by inserting 3, and then we insert 2. So now we'll have 2, 3. We insert 1, so we'll have 1, 2, 3. And finally we insert 4. And so we have 1, 2, 3, 4. That's exactly what we want. And you'll see that in the last case, we were inserting at the end of the list, and we didn't run into any problems. So I think the only tricky part for this one, which is why I wanted to use a single linked list, was to realize that we need to have 2 fields. Now, you might have come up with a different implementation. There may be a way to do this without using 2 fields. You may be able to somehow be a couple of nodes back and be using .get next, but I like to write really clear code, so I've done it this way using 2 fields. All right, that's it for this challenge.